In this video, I'm going to talk about how to deal with vectors and matrices in MATLAB. Keep in mind, this will be a super simplified version of vectors and matrices, since this is a much smaller part of a huge topic in linear algebra. When you deal with numbers, you typically have a scalar or vector quantity. A quick Google search tells us that a scalar is an element of a field which is used to define a vector space. You may also hear the term array, which is sometimes used interchangeably with vector. In layman's terms, a scalar quantity is basically just a standalone value with no direction. So a vector has multiple scalar components that can look something like this. In MATLAB, we can distinguish separate numbers in a vector three different ways. So the first way is with space delimiting. That will look like what I have up above. That's just this. So we have spaces in between here that tell it those three values are separate values. The second way is by comma delimiting. That will look something like this. Now, there's a third way of doing this. This third way will give us this vector right here. This is a column vector. And this one over here, this is a row vector. So the third method is delimiting by semicolons. So that will look something like this. So this, again, will give us a column vector. Something we sort of use to navigate vectors is called indexing. For example, each number in a vector is given a row and column position. I'm going to make another vector here. This value here is in the first row. We have 1 rows and we have 4 columns. So this value 8 has a position of 1, 2. So it's in the first row and second column. Let's say we're looking at the number 13. Number 13 is also in the first row and the fourth column. So this is why we call it a row vector, because all the numbers are in the row. And pretty much the exact opposite for column vectors. All the numbers are in a column. A common way to denote positions in vectors is using the index variables I and j. Like our examples above, we had 1 is going to be I and 2 is j. Another way to think about it is we have row, comma, column. So when we're indexing our matrices or vectors, we always go row by column. So I realized I wrote j and j. Here we have row, comma, column. So I is rows and j is columns. You can use any variable you'd like to set as an index variable. Also, when you deal with like three-dimensional vectors, you'll see it typically I, j, and k. This is part of the reason why I picked I and j. If you haven't seen vectors before, this is just kind of like a standard notation. Some programs you'll encounter will use something called zero indexing. The first index in this vector here, in some programs, will be considered the 0th position. In MATLAB, we call that the first position. To me, that makes more sense, because if you were to count the number of people in a room, you wouldn't start counting at 0, you'd start counting at 1. Other programs like Python, they start counting at 0. Let's talk about matrices. Matrices are very similar to vectors, except they have multiple rows and multiple columns. So here's an example of a matrix. The indexing for matrices works just like vectors, except now you have both dimensions greater than 1. And by dimensions, I just mean the side lengths. We have this side length here, and we have this side length here, and you count the number of columns. For this one, for up here it's 3, and for down here we have 3 as well. Typically, the origin of navigating a matrix starts up here at the top left-hand corner. Normally, I read matrices from top to bottom, left to right. If I were to go through this matrix here, listing off all the values, I'd start here at 0, and then I'd move down to 3, and then I'd move down to 6, and then now we're at the end, so I'm going to go back up to 10, and then move down to 4, and then down to 9, go back up to 13, 5, and then 0. Some people, you'll see that they work across the columns first, so they'll start at 0, they'll go to 10, and then they'll go to 13, and then they'll come back around to 3, go to 4, go to 5, and so on. Either way works fine. It's just the starting point is the most important part. So always start at the top left corner when you're navigating a matrix, because like I mentioned earlier, when you're given, say, if I wanted to find the entry that corresponds to 2, 3, this entry here corresponds to the second row and the third column. So if we were to go to the second row, this is the second row right here, and we're going to go to third column. This is 1, 2, 3. Third column, that is the number 5. Notice that when we write these numbers up here, it's kind of going off of this origin point, the green dot there, and that will be consistent with hopefully every single matrix problem you see.